My name is Samantha Saldana,
And my name is Danica and Madamba, or as I prefer to be called, Dan,
and welcome to Robotics for Dummies.
like us. So before we get started, a little bit about us. This is me, that's Samantha. Me and Samantha have been doing robotics, specifically VEX, for around 4 to 5 years now. We do VRC standing for VEX Robotics Competition. It's reserved for middle school and high school, because as you can tell, we're not in college, but I'm also a very avid protractor fan. What does that have to do with the presentation? Absolutely nothing, but if you have any questions, please do. I'm looking for the best protractor in the world. Samantha?
And I really like classical music, and for some reason, I have a thing for composers with really long names, so I'm a very avid Mozart fan.
So, we're going into history. I know it's kind of weird at a
History.
tech convention, but don't worry, it'll be quick. All right. You need to learn history because this is a world where we do learn about the history of robotics, right, guys? There's me and the robot. We're
Very
conversing,
serene.
very peaceful. There's Samantha with her robot dog, and this is a world where you don't learn about the history of robotics.
Chaos.
Very bad, guys.
Bad.
Really bad.
Yes.
So, Samantha, you want to go in on the
Okay,
first?
so as you can see, we need to learn about the history of anything really. Like we have U.S. history right now, and we're juniors, so we currently are learning U.S. history, and we need to learn from those previous mistakes, because if we don't, we are very prone to making them again, and then eventually lead to a robot revolution. So let's start off with Leonardo da Vinci, or as you guys may know him, Leonardo da Vinci. He is popular for painting the Mona Lisa, but he is also one of the first people to have ever designed a humanoid robot. A humanoid robot is just basically a robot that imitates human motion. And his robot, which was sketched back in 1495, was able to stand up, sit down, turn around, lift up its visor, etc. And it was composed of a lot of pulleys and gears. This robot was named after him, so it is called Leonardo's Mechanical Knight. And we must remember that this was back in 1495, so it was when technology was very primitive, and he could not create it, and the redesign was made until 2002.
Now, you're probably wondering why the term robot? Well, I have the answer for you. The term robot was actually popularized around 1921 by the Czech writer Karel Capek and his movie RUR Rossum's Universal Robot. So what's very interesting is in the movie, it's about synthetic humanoids, and these humanoids, at the very end of the movie, they eventually, okay, don't be scared, but they eventually take over humanity, kill all the humans, and then take their jobs. And thus, that's why they're called robota, or the forced labor of serfs. I know, don't worry, guys.
It's not a big deal.
It's not that bad, guys. Don't worry.
It's not bad. So now we go to Unimate, and you guys might be looking for a face, for eyes, maybe a few arms, but you realize, where is it? So Unimate was actually the first robot to ever be implanted in an industry or in a factory, and it is the first robotic arm. And it was made in 1959 by General Motors, and by its actual creator, George DeVol. And this served as an industrial robot. So if we go back to 1959, we do remember it's around the time when America was trying to evolutionize. So it was able in its brain to record about 200 movements. And by recording these 200 movements, it reduced the amount of time that was spent doing repetitive movements. So say, for example, making a chassis, folding certain metal parts, or screwing things in. It was able to record those 200 movements and then apply them into tasks for every day. It reduced, I think, the amount of time spent on a car by 80%. And this whole idea was introduced to automation.
We also have Shaky the Robot, which is known as the first truly autonomous robot made in 1972. And by autonomous, that means that Shaky is able to act on his own. He first has a human operator, but after that, once he gets the initial command from that operator, he can break down simple commands into his own sequence of actions, which he will perform himself. And he is an optimizer. The algorithm that he actually uses, the A-star surge algorithm, is still used today in GPSs to locate the optimized path from point A to point B.
And finally, we have Sophia the robot. I don't know, raise a hand, anybody know her? Okay, I don't have to do a lot of explaining now. So Sophia the robot was made in 2016. She's 6 years old, smarter than any of us in this room. And she was made by Hanson Robotics. So what makes her so special, and I think you guys can tell, is that she looks like her actual human. It's a bit uncanny for some, but she has 3 main factors, which is artificial intelligence, operating systems, and sensors. And as you can tell, some of her new unique features are artificial skin, which can adapt based to light. You have languages, so if you try to speak to her in Japanese, Cantonese, it will respond back in that language. And she is most popular for having been able to imitate human emotion. So she did serve initially in the research and education field, but after she was known and she became viral, she went to a lot of talk shows, and that's how she became part of the entertainment field.
As she says, who knows, with my science evolving so quickly, even many of my wildest fictional dreams may soon become reality. I don't know, guys. That kind of sounds like the robot revolution to me, but
I don't know.
But now that you know how we've gotten to this point of robotics, let's try to build a robot together. Don't worry, we're not going to make Sophia 0.842875. When you build a robot, the first thing that you should always ask yourself before you get any materials or even think of a design is, what is the problem that you are trying to solve? Let's say, for example, you're having a hard time trying to wake up from bed, right? You're thinking, okay, well, this only applies to like school children, but you're thinking, I know I have to wake up now or else I'll be late to school, but sleeping is so awesome, and 5 more minutes wouldn't hurt,
absolutely
right?
Not.
Wrong.
Oh.
In fact, you wake up with only 10 minutes before school starts, and then you go and look in the mirror, and your hair is all messed up.
Oh, no.
And then you try to look through your laundry to find a decent outfit that won't get you bullied, so you have to wear this to school.
Oh, no.
And as you go downstairs to start your car, it breaks down, so now you have to go and run to school, but as you run, you slip on a banana peel, and then you break your leg.
That's all I
and
can think
because
of.
you break your leg, you can't get your cell phone, which is like cracked across the street. And because you don't have that phone, you cannot call your teacher to stop the bus to go to your presentation at the Southern California Linux Expo. Now, it's not like I have any personal experience, but
Definitely didn't happen this morning.
but okay. When we define our problems, it's much easier to come up with solutions. You should think, how can I fix this problem? So, what do you guys think? If our problem is we're waking up pretty late, you know, we can't get up on time, what should we do? Anyone raise a hand? Yes? Set up an alarm? Okay. You
bad.
in the back? Go to sleep earlier?
Earlier,
Okay, one more. Just don't go.
That's not bad.
Oh, okay, one more. Yes?
Whoa.
Exactly!
Whoa.
He knows what's up.
Yeah.
So, the robot that we're going to make is called the Water Waker 3000, right?
Well, guys, it's going to be
so-
amazing,
so,
guys.
Okay, let me explain, right? So this is us, right? This robot will be a robotic arm that links to our alarm clock, so when it sets off, it dumps water on top of our face. And not to brag or anything, not only would it wake us up immediately, but it would also wash our faces, so we can spend less time taking care of
just
ourselves in the
saying,
morning
like, whoa.
and go to school earlier.
Right.
All right? So, is this an effective solution?
No.
Yes. Okay. I think Samantha's mic is it's a little buggy.
Guys, don't
but,
trust us, no.
Now that we have this solution in mind, right, we can start planning and we can start designing. So here's one of the sketches, right? It's on paper. It's pretty detailed already. But if you want to get even more detailed, or if you don't have any paper around, you can draw it online. Okay, and that may not be as detailed, but it's pretty simple. But there's one more way that we can visualize our design, and that's through CAD.
CAD. Okay, finally, the good part. So CAD is just an abbreviation for computer-aided design, and it is used in 2D and 3D parameters. And the software that we will be using today is SoftSpace, which does mean that we will be doing a live demonstration of our CAD.
Live demonstration? All right. If you want to follow along, you can.
Download?
You can download SoftSpace. If you just search it up on Google, it should be like the first link. Samantha, you want to set it up?
Yeah.
It should be like the first link. And then you want to download the latest version. Don't download a virus, please, guys. I'm not responsible for that. But this is basically And a little example of the Water Waker 3000, yes, we did pre-make this, but it's a very detailed example, it might be a bit abstract to some, especially if you're just starting, but that's okay because we'll just be going over the basics. We'll be making, like, you see how the claw is somewhat in like a C shape? If you want to follow along with us, we'll be making a similar C shape, but very, very simple to accommodate those who are just starting.
And if not, just please enjoy. Just keep watching. Okay, so let us go to our plane. So this is SolveSpace. And as you can see, look, there's a lot of different features on the side. There is a property browser. But before we start, I do want to explain that SolveSpace does require a mouse because a mouse enables all of the 3 main features that it does. So for example, if you right-click and you hold, you can actually move the plane around. And if you had like a drawing on top, it would move along with it. If you left-click and you drag, you could highlight different objects. And as mentioned previously, if there was something on it, you could move it around and you could highlight it. And finally, the scroll mouse, if you click on it and you move it around, you can actually access the 3D parameter. So let's say we wanted to go back to our 2D so that we can actually start making our claw. All you would do is just go to the toolbar on the left and go to the bottom right and click on the 2D shape. And then perfect. We would go back to our X and Y coordinates. So let's start making our claw. Like we said, it is kind of like a C shape. So in order to make a C shape, we do want to access the line feature. But before that, we need a cup. We need to make our cup. So in this case, we will be using the circle feature, and we will sketch circle, and you can click on the screen. And you can drag it around, and you can just click on the screen to like hold it. So you can click on the center of the circle and move it around. You can see that it still moves. If we grab the rim of the circle and you moved it around, it would move. But we do need it to be as accurate as possible. When you're holding a cup, it's not like it's moving consistently. It's like stuck in a certain length. So we do want to switch that out. And in order to do that, we need to apply something called a constraint. A constraint is just basically a rule placed on a geometrical shape. So in this case, the constraint we will be applying on the circle is called diameter or distance. In order to access that, you will go to the very top of the screen and click on constraint. And you can click on the first option that says distance and diameter. And you will see a sequence of numbers. All you have to do is just input the number, input the number that you would like. So any numbers? Numbers? 6. Okay. 1, 5. Did I hear a 40? 40? 40. 40 sounds amazing. Okay. So let's stick with the 40. And let's say that we did want to change the diameter of this circle. All you would have to do is just click on the purple and double click, and then you can just change it. But let's stick with 40. I think 40 is a good number. So let's put that aside and let's actually get to our claw. So our claw is a C shape, and since we actually sketched out our circle using a sketch feature, we can do the same thing with lines. So you would go onto the line feature, and you can just pinpoint all of the points that you would like. And so in this case, we will be doing a C shape.
Sorry guys, I'm a bit rusty.
That's not a C. Anyways, we need to fix this, right? So why isn't this a very good design? Why doesn't this work? Like, exactly. It fits around. Yes. So if we try to move any of the points on the screen, we could see that it's moving individually. It's not moving as a complete shape. And that's not something that we want, especially when we're trying to go into a 3D parameter. So let's fix that. In order to do that, we need to figure out what lines will be horizontal and what lines will be vertical. For those of you guys who have not taken geometry, it's very simple. Horizontal lines go like this, vertical lines go like this. And they will not move from that position ever. So in that case, let's click on a line that would seem horizontal, like that one. That would be good. And we would apply a constraint called horizontal. As you can see, it's very tedious to keep clicking on the constraint and keep clicking on individual lines. So what you could do is just access on a keyboard shortcut and just click on H. So as we can see, all of our lines are horizontal. If we tried to move a certain point from that line, you would not be able to move it from that horizontal position because we applied the constraint. So we would do the same thing for the other lines. Obviously not horizontal, it'd be vertical. So same thing, you could click on constraint, but you could use a shortcut V, which is way quicker. Perfect, now it's starting to look like a C. Okay, so as you can see, we can try and move a point, but it's still moving. This is still not what we want, so in order to do that, we will apply another constraint, another rule on this shape. And this shape will most likely be repeating certain lengths because it is going to be symmetrical. So in this case, we will click on the 2 lines that will most likely have the same length, and we will apply a constraint called equal length, radius, or angle. In this case, it is length. So now if we try to move any of the point on any of the two lines, it would move at the same time. So we could do this to any line, like for example, the two vertical lines, like those will always be equal to each other. Or we can do it to those two inner horizontal lines. And as you can, whoa, it turned red. It turned red. So why did it turn red? Even though those two lines will always be equal to each other, since we already applied constraints to the other two lines that are always going to be perpendicular, you don't need to apply any more constraints. Putting too many constraints can make your CAD go into an error, so it's better to just leave it as it is. And finally, in order to keep it in a nice width, in a nice shape, nice form, you will be adding distances. In order to do that, you would click on a line and a point, and just click on the feature, and you can just put whatever distance you want. So 20? 20? Okay, so we can just apply 20. So we can do that for all of the other lines. Sorry guys, sorry. Give us a second. Oh, okay, so as you can see, it does say 20 reference. So in other words, it just means that you cannot change the distance for that side because you already have applied constraints and you already fixed it on all of the other sides. So finally, we do need it to fit in within the cup because we do want it to hold the cup. So if we remember, our diameter is of about 40. So let's make it have a little bit of leeway. So let's give it maybe 42. So that way it could like slide in. You would do the same thing for the other horizontal line. And let's see if it works. It works. Great. Okay, so finally, we will do something called extrude, which is basically making our design go from 2D into 3D. So we will go onto New Group and click on Extrude. And now we can see that our shape is a solid, so to say, but we can only see it in 2D. If you guys remember, there is a shortcut where you can use the mouse, or you could go to the toolbar at the very bottom and click on the 3D shape. And now you can see your shape in 3D. Very simple, but now we actually need to change the width of the shape since it can't be that thick. Come on, guys. And so we do have two different features, two different ways that you can place them. It's called open one side and two side. One side basically means that the shape lies on the X and Y coordinates. Two-sided, if you click it, you can see that it goes in between the X and Y plane. And if you try to move any of the points, it would be equal on both sides. So finally, all you have to do is just change your distance again. And in order to do that, just click on a line, click your shortcut D, and we can add a distance. 15, maybe.
What distance? Oh.
What distance do you guys want?
Oh, of course.
Oh,
I like that
pi?
answer.
Okay,
That's
okay.
a good answer. That's a good answer.
10?
I heard 15.
15? Please, don't go too hard on it. And there you go. That will be your claw. But it's kind of dull. Let's change the color.
Yeah. What color do you guys want? What color?
Blue.
Blue?
Green.
Pink?
Green.
Blue?
Pink. Olive. Oh,
I
that's
heard
very
neon
specific.
green. Neon green? Is that
Purple. Let's do purple. Green.
Is that a neon green I heard?
Neon green.
I don't know, guys. Neon green doesn't look that good. But yeah, so like we said, this is a very, very simple claw shape. Obviously, once you get the basics, once you start working a lot more with CAD, it should be simpler, and it's not too hard to get a grasp of, especially once you get the basics. We have a little cheat sheet for you. If you were confused at any point in the live demonstration, you can take a picture if you want. We have constrain, equal length radius, horizontal and vertical, diameter and distances, extrudes, the XYZ coordinate plane, property browsers, the toolbar, and dummies like us.
Yay.
So go ahead and take a picture if you would like. And this is specific to SolveSpace.
Yes.
Are we good with pictures? Can I get a thumbs
Can we
up?
continue?
Good with pictures?
All right. Great.
So how does CAD apply to robotics? What does it do? What does it provide?
Yeah, we just did a whole presentation explaining of how to do a claw and how to make the water rig at 3000. But what does this actually have to do with our topic, robotics? So even though we used a very simple example to explain to you guys how to use this CAD and how to apply it to our everyday problems, for some, we can actually use CAD in everyday life situations. So for example, the rovers that we mentioned previously, they were designed in a CAD. And CAD is very efficient when it comes to trying to fix your mistakes. You could try it once and again and again and again. And all you have to do is just change a few distances, and it makes it very easy and accessible to share it with your partners. You could make prototypes, which is basically just a live design, but it would cost a lot to get materials and to consistently make them over and over again. So CAD is very reliable. It is available for everyone, so you guys can just download it onto your computers or laptops, and you can just meddle around with it, actually.
Furthermore, without CAD, we wouldn't have robots such as these. We wouldn't have industrial robots that assemble cars, such as the Tesla arms in Tesla factories to make Teslas. We wouldn't have exploration and education robots, such as the Mars rovers, Curiosity and Perseverance. Or we wouldn't have assistants such as the Roomba, which cleans your grandma's dusty floors. Now, we wouldn't want her to clean them by herself, would we?
Come on, we don't want to do her like that. She can't bend down anymore.
The world as we know it has developed drastically with robotics, and as robotics continues to grow and develop even more, as technology continues to advance much, much faster, we need to remember that robotics should be an assistant.
Not a replacement.
Thank you.
Thank you.
If you have... If you have any questions, feel free to ask. And there's also our emails if you want to ask something else.
Contact us.
Yes.
Question one. Question one. The Water Ranger 3000. When did it wet the bed and ruin your bed?
Pardon?
When the Water Ranger 3000 messed up your bed and wet your bed for longer than a day.
So the question was, would the Water Waker 3000...
Number two, why is it called the Water Ranger 3000 if it's the first prototype?
Wait, sorry, can you say the question again?
Why is it called the Water Ranger 3000 if it's the first prototype?
We thought it sounded cool, so we just put it like that.
So the first question was... okay, I'm sorry. I forgot.
The first question.
When did it ruin your bed?
Okay. The first question was, would the Water Waker 3000 ruin your bed? Yes, that is the purpose.
Unless you have a waterproof sheet, which we recommend. So if you want to get the Water Breaker 3000, I'm just saying.
And then the second question was, why is it called the Water Waker 3000? Because we thought that was cool.
Thought it was a cool name, guys.
Any other questions? Yes, sir? So the question was, what about the robots that are like, they like clean the dishes, serve, and that stuff? Pardon? Our opinion on robots that like do your dishes? I'm so sorry. A robot that does one task like doing your dishes?
Oh. So we did not mention it on the screen, but there is a robot called the Huber robot. It does not look like a humanoid. It does not look like a human, but it does go on wheels, and it does help people who are above 60, I believe, around the house. So it does do simple tasks such as pick up clothes from the floor. It does do your dishes. So it does help a lot. And for example, let's say if you wanted to help in the kitchen, we actually passed a restaurant not long ago, and it was like the flippy robot, and it actually helps you just flip your burgers around. So there are robots that do specific tasks. It just means that you just have to look for them. That's it.
Yes?
Personally, where do you see robots evolving in the future?
So the question was, personally, do you see robotics evolving in the future? Yes, I do, especially with AI. I'm pretty sure you've all heard of AI art and all that. With AI, it's kind of complicated because you don't know if you can take control of it, or we don't know what the limit is, and it's very concerning, especially if it, is taken in regards to safety. But yes, I do think that it will continue to grow and develop, but we're going to have to need regulations in order to protect people's safety, especially. Any other
More
questions?
questions? Oh, I think the person in the back has raised their hand for a while.
Yes. Yes? What drove us to do robotics? I guess we'll both answer that question. You want to go first?
I'll go first. So, oh my God, I'm about to tell you my whole life story. Okay, so it basically started with me being a zookeeper. I was like, animals are cool. But then I'm like, wait, I want to get paid. So I was like, let me be a veterinarian. But then I'm like, wait, but I kind of like math, so let me become an engineer. But I'm like, what kind of engineer? I'm like, I like chemical engineering. But then I'm like, that's too much studying. But it came to the conclusion that I really like the way that robots operate. I really like the concept of being able to create something from scratch, something that you've made. And robotics seemed like to me all of my requirements. It checked everything off of my list, and I still enjoy it to this day. I'm still in the club.
For me, I'm especially thankful for my teachers, my middle school and my high school teachers, because they've pushed me to go into this field, especially when I first started thinking about robotics. I was a wee little kid, you know. I didn't really know what I wanted to do in the future. I was very lost. And then this teacher, my middle school teacher, she was like, "You want to join robotics?" And I was like, "I guess." I don't know what we do though. And she's like, "That's okay. You can start from the beginning, and as long as you continue to work and improve on yourself, you'll understand and it'll be fun." And from that moment, I just really enjoyed robotics, and I've decided to continue it for 4 to 5 years now. So yes, having those mentors definitely helps.
Yes. So, question?
Yes, I had a question. So after you do that CAD design, what would be the next step? Is there like, do you hook it up to a 3D printer or?
Okay, so since we did use CAD, you could 3D print it, and sadly we did not have enough time to actually bring an actual demonstration. But you could print it out in 3D. You could just transfer it onto any 3D printer that you'd like and download it in a certain file, I believe SLSV. And if you do want to, you can just go straight from the CAD into like the construction process, since you have already tested and remodeled it. This is also called the engineering design process. I don't know if anybody's familiar with that, but it's just basically a series of steps that you follow. And say, for example, your final prototype does not work, all you have to do is just go back to that step, or in other words, just fix your CAD up and just see where you went wrong, and hopefully it all works in the end.
Another thing is, especially for us, since we're in Vex Robotics, we usually work with metal pieces. So we just look at the CAD, and then we like try and model we try to model our robot based on what the CAD shows. We don't necessarily print it because we have the materials, like the metal pieces, but if that's, if you want to 3D print it, you have that option. You in the back?
What's a good project for like a beginner project for like someone?
Okay, so his question was, what's a good beginner project? I think a keychain would actually be pretty nice, especially if you have access to a 3D printer. You could learn how to, You can learn how to make that in the CAD, because you have your circles, your lines, and then you can also import different files into the CAD if you wanted to as well. So you can just add on to that, build it, and yeah. So a keychain would be pretty nice. Pardon? A robotics project?
Yeah, electronics.
Oh, electronics.
I can answer
for
that.
beginner.
For beginner, I don't know if you guys have seen, like back in middle school, people would make catapults out of like paper and like wood sticks. Yes, exactly. Just something that would go like this. So same thing, you can do that with CAD. You just have to make like a rectangle, a circle, and then just make the circle into like a hole, and then boom, you can actually make your catapult right there. But it all just really depends on how invested you are in your project. It all requires motivation. So if you're not really interested in the field, it could be difficult to start. But I think a catapult would be a really good starter thing for electronics and for using CAD.
Yes,
ahead.
in the back. Okay, so the question was, what advice would you give in regards to like someone who's just starting? I would say, okay, I know everyone says this, but just have fun. It's hard when you're doing something because you're forced to. It doesn't feel the same as when you're doing it because you really like it. Especially, you'll feel burnout. You won't feel like motivation to actually continue and start. And so don't feel too pressured by those expectations. Just do your own thing, and you have time. You can always try again, and whatever happens, happens,
And the beauty of CAD is that you can design whatever you want, whatever. So let's say, for example, you like Star Wars, right? You can actually make the robots from Star Wars. Let's say, for example, what else? What do you like, Dan?
What do I like?
What do you like?
I like video games.
You like video games? We can actually 3D print like different consoles. We can print out like actual controllers and stuff. So it all just comes down to like what you really like and going for what you like. Question?
Any more questions?
Go ahead.
Yes.
Hi, so I'm just wondering, it seems like you want to teach as many people as possible to go into robotics. And do you think that will help avoid the robot revolution?
The robot revolution.
So
Okay. you
so the
put us in a
question
tight spot
was
here.
the question was we're trying to like spread the word about robotics and stuff. Do we think this is going to help contribute to the robot revolution? Well, avoid the robot revolution. Sorry. No, for for one reason, and that is I'm pretty sure we hope to live. If not, maybe by our own hand. But I'm sorry, I had to. But I don't think it would help us avoid the robot revolution in the sense that we are the ones trying to maintain those robots. If we understand what the robots do and how they operate, then obviously we would have an understanding of how to stop them or how to, solve that crisis if it ever were to occur. Do I personally think it would occur? Maybe.
And as we mentioned, they are robot assistants. We express the word assistant because we do not want them to take over our jobs. So say, for example, it does reduce the amount of time that you can spend on a certain task, but it does not mean that you want to like lose the position that you're currently in. So like we don't want robots right now being like, okay, you guys have 5 minutes left in order to answer questions. It's still like human nature. You still want to do those things. All you need is just a little bit of help. You just need that extra hand. Any more questions?
Any more, or is that?
Go ahead.
What are your favorite robots?
Oh. Do they have to be like real or could they be cartoon?
Anything.
Yay!
Anything that pops into your head.
Wally. Exactly, Wally. So the question was, what are our favorite robots? My favorite robot personally is Wally. Cutest
I don't
thing.
know if this counts, but does Hatsune Miku count as a robot? She's like this Vocaloid. She's a voice bank, and I don't know. I think she's pretty cool.
Any more questions? All right, thank you guys for having us. here.
Thank you.